Hello, everyone. Welcome back to this segment. So, on behalf of DSC Pune, I'd like to welcome you all back. We are waiting for our speaker, Mr. Navin Manaswi, to arrive so that we can begin with the next session. Till then, we are also waiting for some other participants to join in. Also, till then, I'll inform you about the certificates. Regarding the certificates of the session, we have organized a small quiz related to the session. If you have attended both the session, you will be able to solve them very easily and very quickly. So the form link to the quiz will open at 6 p.m. till 6:30 p.m. So please fill the form as soon as possible. And also you can connect us with Instagram, YouTube, or Facebook, LinkedIn platforms for any queries and doubts, or you can simply write in your comments if you have any doubts. Thank you. So till the speaker arrives, I'll show you a small video of deep learning, which I intended to show you in a previous session, which I couldn't. So I'll share my screen and will show it to you. Oh, our speaker has arrived, so no need to do that. So I would like to welcome our speaker, Mr. Navin Manaswi. Thank you, sir, for gracing this occasion. And I'd like you to continue with your thoughts and with your knowledge, so that the students get enlightened and get knowledgeable enough. Thank you so much.
Okay, thank you, Sanskar. Thanks a lot. So I think we have gone through the why, how, and where surveillance is being used. Now we have also discussed a little thing about machine learning and all. So let's try to continue. So we know already. Let me just go very fast. So we have seen like important intro here. Then we go to next. Okay, let me share first my screen. Hmm. Okay. So you can see our screen right now. So we have gone through this our PPT. So first we know that continuous monitoring is difficult for human beings. So and the accurate and the fast response is difficult for any AI. But deep learning can change the game. Okay. Why we need it? Because of all these activities like kidnapping, trespassing, and all. Where everywhere, including bank, manufacturing center, and all. How we can have CCTV cameras, internet facility, software to detect events and objects and all, AI and deep learning. Okay, we also gone through the like video surveillance system, how it started, and right now where we are, and we have discussed about the five main capability of smart video surveillance system, including face license and all these things. Now let's try to
I'm
start
sorry
with
to
the
interrupt you, sir.
yeah.
Please zoom in the screen so that the students can see it. Actually, they won't be able to decipher the
Okay.
text that's very small.
Okay.
Thank you, sir. Thank you so
Okay.
much.
Okay. Okay. Sorry, sir. Thank you. So then we discuss about this machine learning. Okay, what is that machine learning? Learning from data or experience. Okay, in business world we call it learning from data. Okay, we start with the basic model which is used in school and college also, building the linear regression model WNB with the help of the loss function or the cost function. We call it objective function also, and then we learn decision tree, and we know what is the classification problem, yes or no, red, blue, okay, customer will buy or not. So those kind of things are being done in all industry, all telecom, agriculture, digital marketing, healthcare, autonomous vehicles, industrial IoT, smart home, insurance, retail, everywhere. Then we also discuss about how machine learning is being evolved over the time. It it defeated the best chess player in the world long back. It also now defeated the AlphaGo player. So we are now at a higher stage of AI. Then we discuss about two approach of machine learning. First approach is supervised learning. Here we have given x and y. We learn we try to find out the coefficients w and b, which can explain y in terms of x. Okay, we know how to build a model. We extract the features like x1, x2, x3 from the inputs, and we take y from the label, and with the help of given x and given y set, we find out the dependency w and b. Okay, so we want to know the amount of sale in terms of number of employee in the store. You can find the w and b. Y is the sale and x is the number of employee. Okay, you want to find out what is the w and b value with the help of the old data. We have a 1 year old data. We have data from many stores. We learn from all those stores for to find out w and b. Once we know w and b is called model, and once we have model ready, you can use for the new data. Tomorrow, if you want to start a new store, I can tell you how much revenue it can make based on number of employee. That is called our approach. So this is the one approach. Okay, and second approach is unsupervised learning. It means that there is no y, there's no level, just x. Example, suppose you have a customer data, you have customer data for your retail shop. If you are running a big bazaar shop, you know that key customer data like customer age, customer gender, customer location, and all. You don't have any Y there. There's nothing called Y in the that data. That in database, in Oracle database or any database, we call it CRM, customer. Okay, in CRM basically we have data of customers regarding the gender, income, age, location, and all, right? So in that way we only have x1, x2, x3, x4, or sort of, we don't have any y here. In that case we find some pattern which can tell you which customers are similar, which are not similar. Okay, for example, suppose you have 1000 customers and each customer has its on age, income, location, whatever. You have something on the numbers and all. So you try to understand a pattern which can tell that these two customers are similar and these two customers are not similar at all. So based on the distance approach, there are many distance approach which can find distance between two vectors. So there is cosine vector approach. So there are many approach which can, so any customer becomes a vector. Like age is the first number, income is second number. Okay, gender is the third number. So we have a numbers, we have a vector. Okay, first place is about age, second place is income and all. So every customer becomes a vector. Now if you have 1000 customers, means 1000 vectors. Now you can know which vectors are similar, like cosine. Okay, so when they are almost aligned, when their angles are quite similar, we can say they are similar. So we call it segmentation. So we try to find the segment which based on the distance approach or the cosine approach, we try to develop an algorithm which can find out the similar, the groups, the segments, which can be called as homogeneous segment. Okay, so out of 1000 customers, maybe you can find 5 segments or 6 segments or 8 segments. Based on your distance approach, based on a number of things, you can decide you have 6 segment or 8 segments. Now for each segment we make a business plan. Like example, if you want to give the new offer or new coupon to your customers and you have 1000 customers, if you try to give same SMS, same email to every customer, it is not working at all. It doesn't work at all, because customer want personalized. You know what matters to me may not matter to everyone else, right? So I want something which can be good for me. So customer want personalized email, personalized SMS, and that happens only when we have a systematic, we have very scientific segmentation, scientific grouping. So if you group 1000 customer into the 8 or 10 segments, 10 groups, homogeneous groups, each segment has some nature. Like their age group will be similar, their expenditure pattern may be similar. The guy who spends money on some kind of alcohol, the guy who spends money on kids, the guy who spend money mostly on the female items, or guy spend mostly on something, or maybe the frequency of items, frequency of visit, amount of expenditure. So based on all this pattern, basically you can say this 40, this 100 guy are very similar. Okay, this 200 guy are almost similar. This 300 guy is almost similar. You should find some pattern, and if you really identify those segments, you can have very strong campaigns. And this is the one of the best use case of machine learning in industry. All this retail store, all this retail company campaign, ad company and all, they use this kind of approach to find the right segment, data driven segment, not the filter based approach. Okay, age based and all, they have sent. So this kind of approach can create a nice segment for the campaigning, for the powerful campaign and all. Okay. Okay, now machine learning has been solving many problems in the industry, but when you come to the complex problem like video analytics, image based work, okay, sound based work and all, machine learning tend to fail. Why? Because of n number of reasons. First reason is that machine learning generally is a bit tedious when you have huge number of features. Like suppose in a image nowadays we have a 1000 by 1000 pixels. Okay, in that way you have 1 million pixels. Nowadays a normal image has 1000 pixels, means 1000 RGB value. 1 million, sorry. So you have a, if you have a 1000 by 1000 pixel image, it means you have 1 million pixels. 1 million into 3, because each pixel has RGB value. Okay, some may also have alpha also, that is a fourth component, but let's see only RGB right now. So 1 million into 3, 1 million pixel, and each pixel has a 3 value RGB. So you have 3 million, like 30 lakh pixel value for one image. If you want to build a classifier for the cat or dog or human, imagine that you have a 30 lakh pixel. 30 lakh value means x1, x2, x3, x4, x5 up to x 30 lakh. Too much, right? So machine learning tends to fail there because it's difficult for them to manage, because of n number of reasons. It's more tedious. It may fail. It may not be possible for a typical RAM like a RAM of 32 GB RAM to manage everything. So it's nowadays we try to learn from the brain how brain works. So from the brain activities, from the neural activities, we learn the pattern how our brain works. So there are layers of neurons, and in each layer there are many neurons. Okay, so in each layers we have many nodes. Okay, and many nodes. So First layer, suppose you have 100 nodes. Second layer, suppose you have 40 nodes. Third layer, suppose you have 10 nodes in all. And fourth, so finally you have a many layers. In each layer we have a multiple nodes. Now this neuron system, we try to create it. It's called artificial neural network. The neural network is there in the brain, and what we are trying to simulate or maybe copy or maybe get inspired is we try to create an artificial neural network. Neural network of brain is created artificially by us. Like we get first layer having suppose 10 nodes, second layer suppose having like 5 nodes and so on. So and see this way we work it. So for first input, second input, third input, fourth input, simple. Like you say, you just multiply with the weight functions. Weight basically, so w1 into x1 plus w1 w0 into x0, w1 into x1 and so on. Then you sum it. Okay, you sum it. Then you say you also add the b value. B is called bias also, and then you pass through the activation function like a step function or sigmoid function or 10h function to create an output. So this is a very basic model. You can't say even the single neuron basically, it's very basic model basically. So you have a input layer like 3 nodes. You have a hidden layer. It's like only one hidden layer. You can have a multiple hidden layer also. So we can have first input layer. You can have a 10 hidden layers, and then you have output layers. Okay. So you can design based on our requirement, and generally it has like 100 nodes in each layer mostly. So imagine that we create deep learning is new name, the name for the stacked neural networks. When we have multiple hidden layers, okay, one input layer and one output layer, we call it neural network. Okay, so deep learning works in that way, and each layer is made of nodes, and nodes is just a place where computation happens. So x1 into w1, x2 into w2, x3 into w3, and so on. Then we go to the next one. So every node of the next layer is combined function of previous layers all nodes. Every node of the next layer is made up of previous layer nodes. Okay, and so weights are not known to us. So weight function which can associate it here like w1 plus x1 plus w2 x2 and all. So weights is called edges are called weights. These weights are unknown to us. We have to learn by the objective function, by the loss functions. When it gets tuned, when it learns the model, it means we try to decrease the loss functions. In that process, we tune the w, we find w values for each one. Okay, finally finding the w values which can explain the y into the x. So just like it's the next level of our linear regression. So in linear regression we find out w and b. Okay, so we have only one x, we have only one y. Now here also we can have a multiple x, but we can't have a direct function from x to y. We just have a x1 x2 to x1 prime x2 prime x3 prime. Then we again have a next hidden layer x1 double prime x2 double prime. So we can have a multiple hidden layer. So each x1 x2 goes to the next layer, then go to next layer, finally it maps to the y layer. So the weights are unknown again here, and finding the weights are the task of deep learning modeling. In the model, we find out the W eventually with the help of the loss functions. We try to minimize loss functions in this tuning process, and finally W's are found out with the help of these functions. Let's go the next step. Now suppose you when you have a classification problem, what happens in the initial hidden layers in initial. So we have a first right now. This is a typical model, but in the real world, when you go to the next difficult level where we have a convolution network and all, in the convolutions we try to have a convolutions like we have a matrix, filter matrix. It multiply on the matrix of the inputs and keep sliding it. If you study about the convolutions, it's a very interesting activity that is the core part of the deep learning nowadays. So filter matrix is there. It multiply on your input matrix continuously. It have window, sliding window and all, keep multiplying, get a new value and all. So initially in the first hidden layer, initial layer, basically you find out the small patterns, small like cut, like your chin cut, eye cut and all. You find small cut. This is called small features. Okay, and then when you go to the next layer, so in third, fourth hidden layer, you find out the some big pattern like whole eyes, whole ears and all. You find those kind of things. Then when you go to the last layer, you find out the bigger things like almost half face, full face and all. This thing you find out. So basically, we have a huge number of layers mostly in deep learning network, where initial layers are focused on finding out the small patterns, small edges. Okay, like chin cut, eye cut and all. Then you have a small medium features. Then we have a high class features and all. So that is a task of multiple layers. Okay, deep learning networks. Okay, so let's try to analyze more. So when you say convolutional neural network, it's nothing but it use the filters or kernels. So you take a one filter here, like this is filter. You multiply here, okay, and multiply element wise. So 4 into 0, 0 into 0, keep multiplying like this way. 9 numbers multiply, it becomes suppose some number minus 8. Then you slide the filter, slide it, multiply again with the next matrix, and then you create the new numbers every time. And these new numbers in the next, this is happen in the next layers. So input layer, hidden layer, keep moving ahead. Lastly, it's a output layer. That is a typical convolution neural networks. Okay, I can tell you the most important part of the video surveillance. In the video surveillance, we tried or any kind of video intelligence. I can tell you these are the most important computer vision tasks. One is called semantic segmentation. One is a classification. So first thing is the classification problem. Whether the image is a cat or dog, cat or not, human or not. This is called a classification problem. It's a old problem. But nowadays, the advanced AI on this video surveillance and all is all about four tasks. One is the semantic segmentation, like you try to understand the object and then you color accordingly. So what happens? You train a model which can say that if something look like a cat, you can have a you can have boundary and all. You can color it with a yellow. If something is a grass type thing, you put a green and all. So you convert this kind of, you see the image, this image into this one. So this is the original image without this red box. Leave this red box. This is the original image. From that image you learned that this is the cat. So one color thing, coloring part, second, third and all. So in the same way, suppose you have a road. Okay, on the road, left lane, right lane, some kind of car and all. So you can color it. You can have a zone. This look like a car, this box look like a car, this look like a left side road and all. So you color it. That is called semantic segmentation. You pixel wise you identify the object. This pixel belongs to cat, this pixel belongs to the grass and all. So this is called pixel wise, grass, cat, tree, sky, you color differently. Then you have a classification is a known, this is a cat. Also localization, you first find out whether there is a cat or not, and if yes, where is the cat. Okay, then we have a object detection. So whatever object the image has, you can figure out. Okay, this is the dog, this is the dog, this is the cat. And third, last is the instance segmentation. It means that it is a combination of both. It identify the objects and also mask. So this is called masking. This coloring called masking. This is called masking. Yellow masking, green masking. So this instance segmentation is a mix of object detection and the semantic segmentation. It first identify the objects and then it also colors it. Okay. So this is way doing. So dog one, dog two, okay, and then cat. It also knows like there are different cats, different dogs. In semantic one, we only know the dogs, 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 but here we find dog one, dog two, and all. So you have instance segmentations. Let's go deep into that little bit. So semantic segmentation is the understanding an image at a pixel level. We want to assign each pixel. So this pixel belong to the road, this one belong to the bike, this belong to the human being. So we try to assign each pixel in the image as an object class. We assign each pixel to one object. Okay, there are many approach for estimating this semantic segmentation. We also call mask. We get a mask for that. So most common methods are based on autoencoder architectures like FCN, fully okay convolutions network, UNet architecture, and others like PSP-NET and mask RCN and all. So these things are used for the semantic segmentation. So I think many guys know this is like an encoder and decoder architecture. So basically, once first we downsample it, the whole image becomes small, 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 small. This is called encoder style, and then it can also upsample eventually. So this kind of approach first is downsampling path. Okay, downsampling part we try to capture the contextual informations like we know this is the cat. Somehow this big image, suppose this image becomes 1/10 or 1 by 100 small here. Okay, and then it becomes vector type things, then it becomes again the same size image. Finally it will give the colored mask for cat, dog, and grass. Okay, so we have a multiple version of the FCN 32, 16, 8 and all. So based on the image size and all, we decide on all these things. So this kind of design is called encoder decoder network. Like you first encode it, like a you can say that it's like a you can feel this like a decode encoding decoding. First you encode that, then you decode it. Okay, so downsample then upsample. So in a downsampling, what you do is convolutions, you also downsample it. Okay, pooling also downsample it. These two can help you in downsampling. You can have filter, basically filter size is quite big, you can downsample it. You can have pooling also to downsample it. This can help you in downsampling to the small size. Then again you use the upsample, okay, to make it the same size. But now you have mask eventually. You learned it. So everywhere there is a filter, and the filter values are not known to us. We just have a design that this map to this map to this, but the filter or the weight, because weight is called filter also. The weights are unknown here. Everywhere, here to here, weights are unknown. Here to here, weights are unknown. Weight means filters value are unknowns. So the whole weights are unknown to us. We have to train the model based on reduction in the loss functions to find the filter values which can map. Finally what happens, you find out the weights or the filter values everywhere, and which can map x on y. So the pixel value here, each image is a pixel value. This
Sir,
pixel value, yeah, yes, Sanskar.
so I'm sorry to interrupt. I think there's a little connection issue. So can you switch off the video so that we can have a clearer audio?
Which video? Okay, which
No,
video?
your video. Can you just switch off your video so that the audio can be clearer? There's a low bandwidth something zone.
Okay. So I don't know, like now audible. Hmm.
You
Now
are
visible.
audible, sir, but sometimes what happens? You are visible. You are visible. Even the slides you are sharing are visible, but the audio is sometimes breaking. So
Okay,
if you
okay,
can switch off your video, then the audio will be enhanced. The quality of audio.
okay. So how to this stop the video here? This one. This one, okay?
Yes, sir, that's great. But we won't be able to hear you, right? Because you remove yourself from the stream. I'll add you to the stream. You
Okay,
just
okay.
remove your video. There's a option called Start Cam. Please remove that video, your video, which we can see you.
Okay, now we stop the
Yes, yes,
cam.
that's great. That's great. Thank you, sir. Now your voice is also audible. Thank you, sir. Thank you so much.
Okay. Now my screen is visible now? Yes, I guess. My
Yes,
screen is
your
visible
screen is
now?
visible. Yes, 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 sir.
Okay. So basically encoder and decoder. So finally we want to find out W's. Everywhere W is unknown here. We learned the model to find out W's which can map completely this X1. So pixel value X1, X2, X3 and all. This X1's map to the this one y1 y2 y3 y4 and all. So we try to map a function, build a function which can map x on y with the w's on this design. So finally the game is same. The game is the regression model. We want to find out the w's, okay, which can map x to the y. Okay. So I mean, encoder is usually a pre-trained classification network like a VGG net, RESTnet. I think many of you know that there is a uh, classifier. Basically, there is a classifier based on the VGG net, RESTnet, and all. Most of them are developed by the Google team and all. So they are developed to classify objects. That is a cat, elephant, or tower, whatever, flight and all. There is a classifier, and there is like a well-designed models, architectures for the classification problem. Those designs are used in this encoder network. This network is all about those things, and this design of decoder is the upsampling. So upsampling, it's a very smart technology, a smart idea. So that we can map the whole image into the mask image format. So this is the philosophy behind a lot of tasks nowadays. So I think most of the advanced AI in video surveillance, in video intelligence, in the face detection, in all kind of video activities, this kind of design is highly used. PSP.NET is some advanced network. It tries to understand a different scale of pattern, scale of features, and from that they find out the pattern that this is the tower, this is the tree, and all. So it's a one advanced format of doing the same task. Does the same thing. It does the masking, semantic segmentations, but network is bit different. Try to learn many scale of patterns at the same time. Mask RCNN is a very smart way for the instance segmentation. It find out the each person A, person B, person C, cat A, cat B, cat C, and all. So this is a very advanced format. It works on the region proposal network. So it finds the region first, like which region in the whole image where can be the object. First, it try to find out the region. It proposes the region first, or region one, region two, region three, region four, and all. The first idea is to find out the regions where there can be objects. Once we find out those regions, then we find out what is the object in the region. That is a very interesting kind of idea, but it has a high computational cost. So generally it takes huge computation. It needs a lot of GPU to run this model, but the idea is very smart. We find the region first, and then we classify at the same time, so that we can find out the whole object and then mask it at the same time. But YOLO is the advanced. YOLO is just smarter than this technology. We can discuss it. So this is like a semant. This is called instance segmentation. You can see person A, person B, person C, and all different masking and all, vehicle and all. So we can mask, based on the class, based on the one, two, three, person A, person B, person C, and all. So YOLO is a without a reason, without finding on the reason or area where we can find the object. It can does those things together. It is smarter. It is faster, Once when it came, it really surprised the whole industry, whole deep learning community as well, that how it is so fast. It is very fast. On the video, you can just see video is like 24 frame per second, right? Mostly, or 30 frame per second. In 1 second, we have 30 frames. Even in each frame, they can find out the car and person. Generally, this mask arson is time, very costly in terms of time. It takes huge time to find out the result. But YOLO is very fast compared to this mask RCNN. And YOLO can be used for semantic segmentations as well as instance segmentations to train you on your custom data. So you want to focus on the flowers or helmet or chair. So based on your custom data set, you can train a model for semantic as well as instance segmentations. This is the like place you can search it. GitHub mein there is a code here. You can go through the code. You can also try the Google Colab also to run the model as well. So these are the result. Yellow two, yellow two, yellow three, yellow four. Yellow four is very powerful nowadays. Yellow four is the most I can say exciting and most powerful model so far. It inference time is also low, and the size of this model size is also very small. Okay, so yellow 4 is the one of the best I can say algorithm for semantic and instance segmentations. You can try this kind of approaches. So now for the face identification, we have a very old approach. We find the key point in the face, and then the advanced approach of the embedding of finding this 68 key point into the small size vectors, and then we find the person, whether this person belong is X or Y or Z. So face is easy. Okay, number plate is all about OCR based. Okay, it reads the any text. It will find out the number or whatever digit and all. So this is also done. And third part is finding the person, yeah, finding the crowd, and these are being discussed in the whole PPT today. And suppose you want to focus on the event, suppose someone is fighting. For fighting is a spatio-temporal kind of work, because we have to find out in each frame what is there, how many person are standing, and then over the time, over suppose 3-4 seconds, we have 90 frames. In 90 frames, how things have moved, which can give the hint about the event, like fighting is going on, or someone is being hit very hard and all. So event based for event analysis, we have to have frame per frame analysis, like video intelligence plus over the period how things have emerged. Then you can create the event alerts. So these are the main parts of all this video surveillance. I think deep learning is a game changer. It works very fast. It is very accurate, which has surprised the whole industry. And I would like to welcome most of you to join this computer vision world, join this video surveillance world, and help the industry. And we are also working in this area. We have some client who needs the ATM video intelligence, which needs the premise intelligence. So we are working with the clients also. If anyone wants to contribute to our company, please message me also. We can work together. Yes, Sanskar, I think for my side it is done now. If anyone has any questions, I would like to answer it.
Okay, sure, sir. So I would like to open doubts for everyone. So the doubt session is open. You can write out your doubts in the comment box in the chat box section, so that I can read it out and sir can answer it. Meanwhile, I'll tell you everyone about how will the certificates be provided. So the certificates will be provided via quiz. So we'll be taking a quiz, and the quiz will be open from 6 p.m. to 6:30 p.m. I'll share you the barcode and the link. not in the WhatsApp, in the session itself. I'll share it with you via screen sharing. You can scan the barcode, or you can use the link to go to the quiz and solve it. And depending upon your credibility, we'll provide you the certificates on your mail. And any doubts from anyone? Also, the quiz will be based upon the teachings of taught by Mr. Navin Manaswi sir in this session and the previous session. So you don't need to worry about the course. And I assure you that the quiz will be easy enough. So if you have attended and listened to the session attentively, so you'll be able to answer all the questions.
Okay, no worries. So any question, anytime you can just message me also, message Sanskar
Okay,
also.
I have a question from Viplav Anand. He's asking, sir, for machine learning, do data science is important? So he's asking that is data science important for machine learning?
Okay, machine learning, basically the whole package of data science is very interesting. The package of data science also includes machine learning. Without machine learning, data science has no value, no meaning. Data science means you must know machine learning, you must know data visualization, and you must know little bit of data preparation. So, and you must know little bit of uh, business world. That's all. So data science is a mix of
Or
machine learning. Yeah, all these things.
Thank you, sir. Also, I have a question from Praveen Bhatt. I just started deep learning course. So, sir, would you like to elaborate upon how the course goes, or what? Like I asked also in the previous session for the ones joining new in this session, you can just retell them what we discussed in the previous course about deep learning and how should we start it.
Yeah, I think there are many courses, Udemy and all, so you can take any course. But I think I suggest you to take some remote internship or some mentorship, which can help you with some real problem and some good resources. So courses may not be the only way and the best way I can say. If you have a real problem to excite you, to inspire you, and if you have some good resource to start the game, I think you will find your own way. So, but I can suggest one thing: you just start mastering the pandas, numpy, this kind of thing, and then you can master the machine learning very fast, and a skill and package also. For deep learning, I think take some mentorship or take some remote internship, and take the real problem or real challenge, and automatically you will find the way out, to learn and master and be smarter, I think.
Okay, so there's one more question. There are, in fact, many questions. Uh, One anonymous person, I don't know his name, it's test series written. So he has asked, is TensorFlow used in industry on edge devices?
Yes, we use that. Yes, so we call it TF Lite. To TF Lite is there for edge devices. Yes, we do it. We right
Okay,
now
thank
we work for some client, and that client have a Raspberry Pi and all, and we develop the deep learning model which can be deployed on Raspberry Pi and those kind of chips.
Okay, so thank you. And then there's Vartika. She's asking, what are the career opportunities of data science?
A huge. I think every industry is using data science in all possible way. So I think whole industry, whole business is ready to take the data science professionals. I think there are huge scenario, huge use cases. It's up to only your creativity, up to the business creativity to create a new data science project. So I think a huge carriage. I don't think there is a second thought about that.
Okay, so there's another one from Mohit Mehta. Sir, what are your views on autonomous driving cars combined with data analytics?
Autonomous vehicle, it's a very interesting kind of project, and it needs a very advanced deep learning thing because the accurate as well as very fast. So even you make very accurate model, deep learning model, but it is not so fast. So there would be accident, because if you have lag, you can you will not put a brake fast, so it can there can be accident. So data analytics is not so much common in this autonomous vehicles. I think deep learning and deployment and the lidar and all these are the most important part of the autonomous vehicle. Data analytics, I think, is not linked with these autonomous vehicles. Data analytics is used mostly for the business analytics. So you have to analyze the top 10 vendors, top 10 suppliers, right kind of, so those things we use the data analytics, to understand the pattern among the vendors, suppliers, among the employees, among some activities. So those are different world, like they are not same, they're different world altogether.
Okay, so here's a question from Neha Kopikar. Uh, she has asked which framework is used widely in industry, PyTorch or TensorFlow? TensorFlow. I'm sorry.
Okay, very nice question. TensorFlow, I can say PyTorch is picking up nowadays, but I can say TensorFlow is used more because of n number of reasons. Because TensorFlow can be also used for mobile also. It has more advanced version. It has a lot of inbuilt models. Uh, PyTorch is also picking up, but I can say TensorFlow if you give me choice.
Thank you, sir. Now we have Pratik Mali. He has question: is YOLO V3 used in the industry?
Yes, yes, yes. Answer is yes.
And okay, thank you. And would you like to elaborate something about YOLO V3 and its usage in the industry?
So, suppose you want to identify, you want to segment, okay? Suppose the person, you want to identify a person with a phone in ATM. So, you want to find out helmet person, right? So, in that case, generally, typical classifier doesn't work nicely. So, classifier, so what happens for that? We try to build a YOLO model. YOLO model is very accurate and very fast. So, you try to use,
Okay, sir. Thank
yeah.
Yeah, you can continue, sir. I'm sorry for interrupting.
Yeah, well, this is like a YOLO can be used on the custom data, or maybe they also have a trend model basically, but you can also build for your data itself.
Thank you, sir. Any other doubts or queries, you can post a comment in the chat box. Our mentor, Mr. Navin Manaswi, is here to answer all your queries. Um, let's wait for 1 or 2 minutes for any other queries to pop up. Till then, I'll share the screen with you uh, and show you the. Okay, a question from Mr. Praveen Bhatt. Just a minute. Praveen, please ask your question. Hi, Praveen. If you can hear me, please ask your question. You can write in the chat box itself. And okay, so there was a question from okay, Praveen is asking why we multiply the derivatives to find the change in weight and with respect to the output.
Okay, so we want to tune the weights, na? So each time we need to tune the weights, which can map X on Y, right? So finding the right W, you have a back propagation method. So you try to minimize the cost function. So generally what happens, you have a from the Y end to the input layer, you try to get the differential. So why you multiply? Because we want to find out W, na? W guys think how to find W without having derivative. You need to have derivative, na? The cost functions need derivative. The cost function needs derivative basically.
Okay, sir, thank you. And then there's a question from Mr. Prateek Srivastav. I'm sorry, my Chrome is a little bit slow and it's not responding. If you can read it, it's telling how should a beginner start and how much does it take to master DS and ML, where and how. Once a minute, just a minute. Sir, can you read that question from Mr. Prateek? Because my Chrome is not responding and I have some issues with the
How
scrolling
should
up
I
and down.
how should a beginner start and how much time it takes to master DS and ML, where and how to find a mentor or mentorship. So beginner can start with I think learning the pandas and numpy in Python. Okay, and then practice with the real problem. You can find problem on a Kaggle, old Kaggle problems, or there are many sites which have many problems. Okay, you can search here machine learning problems. You will find out many links. You can start solving those problems. And for deep learning, I think all about working on an image and all, and how to find a mentor. I think if you have a nice GitHub, if you build some nice code, if you solve some real problem which is available in the market, you can showcase in the on a GitHub, and then approach any company who works in AI. You can also approach me also with your GitHub that I have built something. I have good, I have good understanding about machine learning and deep learning and all. I have solved this problem. Please review it and give me a chance of it does even how it works in industry. Yeah, I answered it. So with Kumar asked the same question: how can we find mentor? Yes, showcase your GitHub basically, and also mail to some company or some person who work in AI space. Okay, I think Sanskar, are you there? Yeah, I think Sanskar, are you there? Some network issue I think is there. So
Hello, sir.
Devans is okay.
Yeah, there was some issue with Sanskar's net. I think we can wrap up the session. It was a pretty good session. I really thank you for your support, and I really thank the audience for listening to sir. And I would I would like to thank on sir on behalf of DSC BVB Pune for taking this session. Thank you so much, sir.
Okay, thank you, Devans. Thank you, audience, for having nice session. Thank you.
Thank you, sir. So before I end, I have an announcement for the audience to make. Um, we will be sharing the QR. We'll be sharing. I'll be sharing my screen right now, so that I can share the link where the certificates will be generated. The link is valid for till 6:30 p.m. only, and it has a small quiz containing questions from the from the sessions that sir took. So I would just share my screen. Just give. This is the QR code and this is the form link. It's bit.ly/vsdl-dsc bvb Pune. The form responses would close at 6:30 p.m. So please make sure to fill this form till 6:30 p.m. Or you can just scan this QR code, or you can access the form at this link, at this URL. Okay. That's all from our side. Thank you, audience. Thank you, everyone, for joining us today, joining today evening. And with that, I take your leave. Thank you.